Hi everyone, in this video we're going to have a look at chapter 6.2. So 6.2, function and relations. To start off, we're going to have a look at, we're going to say that the mathematical language, notation and functionality concepts will be introduced in this chapter, and we're going to continue using those throughout all the other subsequential chapters. So within this chapter, functionality concepts will be illustrated using now familiar polynomial relationships. So they'll be also applied to some new relationships. So first up, relations. So a mathematical relation is any set of ordered pairs. Ordered pairs may be listed or described by a rule or presented as a graph. Examples. So it could include A is equal to the set of the points -2, 4, 1, 5, or 3, 4. Okay, so we're saying A is 3 different points, -2, 4, 1, 5, 3, 4. Where the ordered pairs have been listed, we can say B will be the points x, y, such that y is equal to 2x. Where the ordered pairs are described by a linear function or linear equation. Okay, y equals 2x is a linear. C could be the set of x, y such that y is actually less than 2x. The ordered pairs are described by a linear inequation. So these relations could be presented visually by being graphed on coordinate axes. The graph of A would consist of 3 points, B would be a straight line, and the graph of C would be a closed half plane. We'll be looking at these examples shortly, but for now, let's draw them out. So we said A is the 3 points -2, 4, 1, 5, and 3, 4. About there. So that's A. B is going to be defined as 2x, so that's a straight line. Looks something like that. And C is going to be the inequation, y equals less than 2x. So this, and it's going to be coloured in because we've got an inequation. Next thing to look at is domain and range. And I think we've spoken briefly about this before. So for a set of ordered pairs x, y, the domain is the set of all x values of the ordered pairs, and the range is all the y values. So domain is all the x values, the range is all the y values. So for A, so looking at A, the domain is all the x values. So it's going to be between -2, 1, and 3. So the domain we say is -2, 1, and 3. Because they're points. And the range is going to be 4 and 5. Okay, I can't draw these squiggly brackets very well. For both B and C, the domain is going to be all real numbers, okay, because we go from basically from negative infinity to positive infinity. So we can actually say two things. The domain for B goes from negative infinity to positive infinity. Well, instead of writing that each time, we can just say R, all real numbers. And same thing for C, okay, because we go from negative and positive, we can say that's R as well. And the range for B is going to be the same thing, because we go from negative infinity to positive infinity. And same thing for C. So the graph of any polynomial relation normally has domain of R. So most functions have R as their domain. For some practical situations, restrictions have been placed on the values of variables in some polynomial models. In these cases, the polynomial relation has been defined on a restricted domain. So this will be looking at chapter 1, but as an example, let's say we had y equals 1 on x, okay, wouldn't have a domain of R because we can't include x equals 0. And why is that? Because we can't divide by 0. So at that point we have a missing spot, so we don't have R. We have something very close to it, but we'll be going through that example in chapter 1. So just keep that in mind. Most equations will have domain of R. Now, looking at what we call functions. A function is a set of ordered pairs in which every x value is paired with a unique y value. Definition to write down in your summary books. So a relation A for A and B are functions, but not every relation is a function. So we've got two relations A and B. Okay, these are functions, and we say not every relation is a function, however. The relation C, for example, is not a function as it contains many points. So what we're saying is every point of x has to relate to a unique point on y. So A and B is true, because this point here relates to a unique point on y. This point here relates to a unique point on y. Two different points. Same with B. I can draw two points and they're going to be similar. But for C is not going to be a relation, because I can choose x equals 3, and sure, we could get this point up here at y equals that would be 6, okay, but it's also true for this point here. So for x equals 3, it's also contained y equals 2, for example, okay, because we've got an equation, okay, because x is greater than 2. So what we're going to look at now is what we call the vertical line test. So functions can be recognized from their graphs by the vertical line test. Any vertical line which cuts through the graph of a function will do so exactly once. If the vertical line cuts the graph at more than one place, the function or the graph is not a function. So for the first one, so going vertically for every point here, okay, touches the graph once. So A is a function. Okay, for B, I can draw a vertical line here and it touches the graph once. I can draw a vertical line here, touches it once. And same thing for this one. Okay, so for any point on that graph, okay, I get one intersection. So B is a function. But for C is not a function because this vertical line here touches many points down here, as with this one.